Hi and welcome to another dyno video. Thanks to my friend Ulli, I am able to test this legendary amplifier made by Rockford Fosgate. I'm talking about the Punch 45 HD. The amp was defective, but troubleshooting was easy because these amplifiers feature PIM boards, which means punch input modules, which almost always feature leaked out capacitors. I mean the SMDs for face-mounted capacitors, 10 microfarads, 16 volts. After all the years they tend to leak out and damage the board and damage the traces, and you have to replace the punch input module. But I was lucky, I just had to replace 2 capacitors and I had to add 2 resistors, so it was a quick fix. And after I adjusted the bias of the amplifier, it was ready for the dyno. In most cases, the plugs for this amplifier range are missing. You can use a connector which is usually used for a PC graphics card power connector. So pin 1 is not used, pin 2 is the right channel positive, pin 3 here is a left channel positive, pin 4 is for the remote, and pin 5 is a right channel negative, and pin 6 is a left channel negative. And if you want to run the amp in bridge mode, just connect your speaker or subwoofer between pin 3 and 5. The amp is rated 22.5 watts per channel into a 4-ohm load at 0.05% THD. The amp features a power LED, a gain knob per channel, the punch base and the treble knobs, and the 6-pin connector. On the other side of the amplifier, there are just the connectors for battery plus and ground. But before I start the dyno, you should check out very nice videos of the Punch 45 HD made by my American friend Derek Williston from Williston Audio Labs or oldschoolstereo.com.
The amplifier is connected to the dummy load. I start with 8 ohms mono. I know that the amplifier will do around 50 watts if I only load one channel. I tested that before, but I only test all channels driven. I start with 1 kHz into a 4-ohm load per channel, both channels driven. Let's check out what the amplifier can put out. Go to the clipping point. That looks dirty. Take this one. I got a peak voltage of, here it says 36 volts. And I guess it's fair to use 36 volts. Bridged mono into a 8-ohm load, the amplifier is doing 83 watts. That means I have 41.5 watts per channel into a 4-ohm load, both channels driven. I do the continuous power test again just to demonstrate the power supply voltage, if it's sagging or not. I connected the voltmeter to the terminals of the amplifier, and now you can have a look at the scope if there is some sagging, but I guess 10 amps will not hurt the power supply. Clipping, it stays at around 14.5 volts. I calculated an efficiency of 56.7%. Now I'm checking if the amplifier has some amount of dynamic headroom. It starts to clip exactly on the line where I measured the output voltage. I reduce a little more. So that means we have exactly no dynamic headroom. Amplifier goes into clipping at the same voltage value. And now continuous power test, but this time with a 50 Hz input signal. Let's have a look what we get here. Wow, the same output voltage. I'm checking if it looks okay. I can reduce a little more because we have some slightly clipped positive waveform. So I give it another try. I would say this is a nice waveform. So I go to the top. Do we have 36 volts? We have 35.2 volts. We have 39.7 watts into a 4-ohm load per channel, both channels driven with a 50 Hz input signal. And now the Punch 45 HD is connected to a 4-ohm mono load. That means I test 2 ohms per channel. I start with 1 kHz. Let's try to catch a nice waveform. Here it goes into clipping. I would call this a nice waveform. And it says 34.4. I would say it's fair if we calculate with 34.4 volts. The amplifier delivers 151.7 watts into a bridged mono 4 ohm load. That means I have measured 75.8 watts into a 2 ohm load per channel, both channels driven. And here's a second run with 1 kHz to check out the amperage and the voltage of the power supply. Here we are at clipping. 18.4 amps and 14.4948 volts. I calculated an efficiency of 56.9%. And again I try to squeeze out some dynamic headroom out of the amplifier. Catch the burst, 20 cycles, 1 kHz. What about this? So we have 34 volts, this is no dynamic headroom. The next continuous power test with a 50 Hz input signal. That looks bad. We can take this one. And I got a peak voltage off. It says 34.4 volts. That's not true. We have, I would say, let's calculate with 33.6 volts. Bridged mono into a 4 ohm load. The amplifier delivers 144.7 watts. That means I have 72.3 watts into a 2 ohm load per channel, both channels driven with a 50 Hz input signal. And now two 1 ohm resistors connected in series are doing the job to simulate a 2 ohm mono load. That means I'm testing 1 ohm per channel. Continuous power 1 kHz into a 1 ohm load. It's doing some power. Wow. Let's take this. I have a peak voltage of 28.8 volts. Mono 2 ohms, the amplifier delivers 207.4 watts. We have 103.7 watts into a 1 ohm load per channel, both channels driven with 1 kHz of continuous power. 31.4 amps at 14.48 volts. I calculated an efficiency of 45.6% if the amplifier is loaded 1 ohm per channel, both channels driven. The next continuous power test with 50 Hz input signal. Oh, it doesn't like 50 Hz. This test is not valid. Something's wrong with the negative rail voltage, or we have some protection circuit issues. I don't know. Dynamic power test, 20 cycles, 1 kHz. And I jump directly to the last cycle. And let's try to increase input signal. The line is the continuous power line, but we don't have more voltage, so there's also no dynamic headroom. And now, just for fun, I try a 1 ohm mono load, but I will start with dynamic power test 1 kHz and I start with 1 cycle. That means a half ohm per channel. There's still output voltage, I increase. And now we have signs of clipping. This is the maximum output voltage, 20.8 volts, 216 watts into a 1 ohm mono load. That means 113 watts into a half ohm. Don't take this test too serious, this is just a joke. The amplifier has to deliver output power for just 1 millisecond because I used 1 cycle of 1 kHz. In this 2 ohms mono test, we saw at 50 Hz continuous power we have strange behavior of the output signal. Now I try to fill the amplifier with a tone burst of 50 Hz and 5 cycles. That means a signal length of 100 milliseconds, and I catch 1 burst, and you see these look clean. And now it starts. Here is the problem. And now I increase input signal. Let's have a look. When I increase, the first looks relatively okay, but then it starts. Now I increase the frequency of the test signal to 100 Hz. Let's check it out. We have 5 cycles. They look clean. Let me increase the input signal. There we get clipping, but not that problem we had with 50 Hz. With 100 Hz and 5 cycles, the amplifier delivers at this point 185 watts. Mono 2 ohms. That means around 92.5 watts with a 100 Hz input signal at the highest cycle. Let me know in the comments, what do you think is the problem? Rail capacitors, protection circuit, maybe different problems? This problem does not occur if tested with 1 kHz.
Please don't forget to like or subscribe if you like what you have seen in this video. Thanks for watching and see you next time. Bye bye.